Okay, and we should be live and up and good. Live and running. Let's just see. Yeah. Cool. Okay. Testing our code. So last lesson or last stream we did hang on. Yeah. Last stream we did we finished off control flow, and now we are on to error handling. Okay. So so you've written a program a few times. Close these. And it appears to work. What now? Your program is entitled no conditionals. What I'll do first is I will actually go to my notes, get rid of these, and we'll create a new chapter. And then scroll all the way down and we'll do chapter, what was it, 13? 13 error handling. And then we'll do this, and then we'll do that. Cool, now we can start making notes. Okay, cool. All right, notes. Consider this program. Okay, so we have a void return type of compare, and this with the parameters of integer x and y. If integer x is greater than y, x is greater than y. If x is less than y, x is less than y. Else x is equal to. And we've got enter a number, enter another number, and we're comparing x and y. testing your program in small pieces. So the first testing we're going to be doing is informal testing. One way to test code So let's do that. Let's get rid of our previous one. And then we want to test the following function. For simplicity, we'll ignore that y sometimes counted as a vowel. So bool is lower vowel, and we're bringing in a character. And then we're going to be switching C to case A, case AE, case AEI, I, O, U. And then in each case we will return true. Else the default, i.e. if it's not AEIOU, the default will return false. Then that's right, because I didn't do that. And then in our return type integer main, we will produce a standard character output is lower vowel, also A, and then standard character output is, so that should be in character, is lower vowel Urdu P. And then we'll return 0. So I run that, and you can see we get 1 being true and 0 being false. Okay. The only problem I would assume with informal testing is, whilst you can delete it, you have to do it every single time. So there must be a better way. Preserving it. It does. Yeah, that makes sense. Oops, wrong one. Okay, so as you create more tests, you can simply add them to the val function. Yes. Sorry, I didn't actually read that properly. So you're creating either here. Automating your test functions. One problem with the above test is that it relies on manual verifying. This requires you to remember what the expected answer was at worst, assuming you didn't document it, and manually compare the actual results. We can do better by writing a test function that contains the test and the expected answers and compares them so we don't have to. So if we actually now add, so returns a number that the test we'll create a int test vowel, and then in the block, if is lower vowel is a, then we return 1. If is lower vowel Q, return 2. And then because we have a return type of integer, we need to return an integer 0. So then in our main function, we can do int result test vowel, i.e. initializing it with test vowel. Then if the result doesn't equal 0, i.e. is not false, we return standard character output test vowel test result, 1, 2, 3. um, failed. Else, if it does equal 0, test vowel tests passed. Now when you call any time the previous. Okay, so now unit testing. Because writing functions exercise functions to exercise other functions is so common and useful, there are entire frameworks called unit testing frameworks to help simplify all of this. So basically third-party libraries is what he's talking about. Okay, integration testing. Okay. Yes. As soon as you've included things like if statements or logic or functions or whatever. Okay, code coverage. Okay. So code coverage is how much source code is tested. And then we have statement coverage. So So we got foo with a parameter of integer x, integer y. We're initializing z as y. If x is greater than y, z is equal to x, return z. Yeah, because you would need to make true, and then you would need to make false. Branch. So you got statement coverage. Now you have branch coverage. Refers to the percentage of branches that have been executed. Each possible branch is counted separately. An if statement has two branches, i.e. true and false. If there is no corresponding else, a switch statement can, even if there is no, okay, yeah. Because an if statement, even if it doesn't have an if statement, will still be true or false. And a switch can have many branches. So statement coverage, so in our int, we got an if statement, i.e. this is the first branch, and then yes. So then here, in the lower vowel function, let me just copy that actually, just realized that. In the lower vowel function, two calls will be needed. You need to put A, E, I, O, U, or S or W for the second branch. Now consider the following function. So we got a void function called compare with parameters of integer x, integer y. If x is greater than y, x is greater than y. If x is less than y, x is less than, and if x is equal to y, else if both of these are false. So if this is false, we go here, and if this is false, we then go here, because both of these will be false. So you got case 1, case 2, case 3. 3 calls are needed. 3 calls are needed to get 100% branch coverage. And Yeah, that makes sense. Okay. Then we got loop coverage. So we've had statement coverage, we've had branch coverage, and now we have loop coverage. Loop coverage, informally called the 0, 1, 2 test, says that if you have a loop of code, you should ensure that it works properly when iterated 0, 1, 2 times. If it works correctly for 2, yeah. So I'm actually going to write that one this time. So include input output stream, a void return function of spam with int times to print, and then here we will have a for loop with integer of count initialized as 0, and then whilst count is less than times to print, we will increase count, and then we'll do spam. To test this loop function properly, you should call it 3 times. So let's call it. In our main function, we'll do spam 1, spam, that should be that actually, and then spam, spam, spam. So we've done iteration 1, we've done iteration 0, iteration 1, and iteration 2. Okay. Testing different categories of input. When writing functions to accept parameters or accepting user input, consider what happens with different categories of input. In context, where we are using the term category to mean inputs that have similar characters. Okay. No. For example, if I wrote a function to produce the square root of an integer, what values would make sense to test with it? You'd probably start with something like 4, but it would be a good idea to start with 0 and a negative number. For integers, you may consider if your function, okay. The best practice is to test different categories of input values to make sure that your unit handles them properly. So what is branch coverage? Branch coverage is testing things such as if statements and switch statements. Yeah. How many tests of the following would you need to minimally validate that it works? So you need 1 for true, you'd need 2 for y, and you need 3. So 3, unless you need 4 for switch, so I'll go with 3. 4, okay. 1 to test AEIOU, 1 to test default, 1 to test is lower value. Yeah. Okay. So for the yeah, that makes sense because this is going to be true or false, isn't it? Because it's a Boolean. So for the following code, you would need 4 tests. First test for the above cases. Second and third test to test true and false for y is vowel, and then the 4th test for default. Common semantic errors in C. Okay, so next. So semantic errors are when you enter an incorrect variable name, like if your variable name was I don't know, what would be a variable name? Number, and you did numbers, right? Semantic. Uh, okay, yeah. So, conditional logic errors. So here we've got include inbox stream, integer return type main. We've got a standard character output enter an integer. We've got an uninitialized x. We're allowing the user to enter x. If x is less than or equal is greater than or equal to 5, if x is greater than or equal to 5, then we say x is greater than 5. Okay, yeah, so if the user entered 5, then it would say 5 is greater than 5. That's nice. That makes sense. So you got standard character input into an integer. We got integer of x. We're allowing the user to enter. We're initializing count as 1. Whilst count is greater than x, increase count. And then we're doing standard character count. And then we're producing a new line. So whilst count so count is 1, and if the user enters 1, I think the best way to look at it is to do it yourself. Include string. Okay, so it won't print anything. Because, so what if you did 1? What if you did 0? And then it would print. So instead you would want to do if count. If count is less than 0, or is less than x, i.e. Okay, so infinite loops. Okay, infinite loops. So the while loops, i.e. an infinite loop is when your while loop condition is true. So again, I want to practice return type of integer for our main function. While, now we do int count 1, initialize it as 1, and then we'll do while count is less than or equal to 10. We will do standard character output count with a line break. Then outside of our while loop, and I forgot the block, we will be doing standard character output line break. So since we're not changing the value of count in any way, this condition will always be true. So let's clear my terminal and let's see another infinite loop. 1, 1, 1, 1, 1, 1, 1. And you can see how many ones I got printed. Whereas just to prove it would work, if it was 10, we wouldn't get anything. Infinitely. What is wrong with the following code? So we got unassigned integer of count 5. When count is greater than or equal to 0, deduct count. Well, first of all, I know, hang on. If count is equal to 0, blast off. I don't want to see the answers. So what I'll do is I'll do it myself. Return type integer for our main function. We will do for unsigned int count and initialize it as 5. And then if count is less than or equal to 0, we will be deducting count every iteration. So then if count is equal to 0, we will do standard character output blast off. Else we will print count. And then outside of that for loop, we will be doing standard character output line break, and then returning 0. Okay, so what is wrong with this code? So let's run it. So it's an infinite loop. I have copied it correctly, right? Unsigned int. So the main issue here is if count is equal to 0. So if count is greater than or equal to 0, we will continue the loop. So does that mean that we won't actually reach blast off until we reach -1? Also, our unassigned integer will create overflow. So if we did that instead, and we did if we did that instead, would that fix it? Yes, it would. So the unassigned integer is what is causing the issue in that scenario. because the unassigned integer, remember, going back, your unassigned integer cannot go under 0. And it creates overflow like that. Okay, I still wanna make a note of this. Errors. So you got for int whilst count is less than 5, we'll increase count. So we might expect to go from 1 to 5, but we'll only go from 1 to 4 because 5, the condition will become false and stop. The iteration will stop when count is less than 5, not equal to 5. Less than or equal to. Exactly. So we'd rather use that. Such as using less than, rather. Incorrect operator precedence. So what is the issue here? I don't want to look at the answer. So I'm going to go here. I'm going to do input output stream, return type of integer for our main function. Then we're going to do int x 5 int y 7, and then we're going to say if x is not greater than y, which is a bit weird, then we're going to do standard character output of x is not greater than y, else x is and then coming out of that we'll return 0. 5 is greater than 7. See? There. So that's the issue there. We shouldn't have that there. So then if we got, yeah, no, but still, I don't think that's, even if you put it in brackets, you should just do that. 5 is, so you still get 5 is greater than 7. No, because you need to do this. If x is, you would do that, wouldn't you? 5 is not greater than 7. There we go. Perfect. But still, precision, quite a lot. Precision issues with floating point types. And remember, with floating point types, to make sure it doesn't become a double, we need to use the f after the final decimal point figure. So the following floating point variable doesn't have enough precision to store the entire number. So we got a float of f and this, and we have standard character output. Yes, that's because we need a double float or a float was it? Integer division. Okay, I'm just going to take a quick break here and I'll be back in a minute or so. Okay. Cool. Right, let's continue. Integer division. Remember, we're doing common semantic errors. We mean to do flow. Yeah, that makes sense. So what you could do is you could do static cast. You could do then float, and then x would become a float, and then y would become a float. Because remember, if you divide a integer by a float, then it becomes a integer by default, I believe. Yeah, there we go. Exactly. Static cast to make it floating point. Okay. Accidental null statements using unsigned. Okay. Accidental null statements. Yeah, there we go. So we've done a semicolon here. This is essentially when we close a statement early by accident. Not using a compound statement when one is required. That is because we haven't used a body block, sorry. So if we just show it here, integer return type of main. First of all, we want a void blow up world, which would then produce a standard character output of kaboom, kablow. So then in our main function, we will have should we allow the world to blow up. And we'll be doing yes or no. Then we will want a char C of empty, and then we want a standard character input of C, but we need a semicolon there. So then we will do if c is exactly equal to y, then we will do a standard character output of OK. Here we go, Fabrizio Romano. Then we'll do blow up world, and then outside of the return statement, outside of the if statement, we will return 0. So then we'll clear the terminal, we'll run the code, and as you can see, oh no, that's not the main reason, we haven't done that. Should we blow up the world? Yes. Kaboom. Kablow. And then should we blow up the world? No. And it still blows up. Should we blow up the world? Q. And it always blows up. That is because we have a dangling if statement. So if we do a block with our curly brackets, we should now find, no, we shouldn't blow up the world, and then it exits. Cool. i.e. not using a block statement for the following if statement logic. This, so not using a block means that the blow up world function is always going to run regardless. Okay, that makes sense to me. All right, because the assignment operator, yes. So the assignment operator of equals assigns a value. The equality operator of checks if the values are equal to each other. So here we're using the assignment operator instead of equality, and again that makes it run. So that's very important. I don't feel I need to code that out again or change it because I feel I understand that. And then finally, for getting to use the function call operator within a function. i.e. using, i.e. calling a function but not using when needed. such as that. Okay. Detecting and handling errors. How are we looking on the progress? Okay, so we might finish today. Okay. Yeah, you can ignore that. Okay, detecting and handling errors. So, I go. So, three places where assumption errors typically occur. When a function returns, the programmer may have assumed the function was successful when it was not. The program receives input from a user file. When the function has been called, the programmer may have assumed the arguments would have semantically been valid when they were not. Those three errors. Handling errors in functions. Handling errors in functions. Okay. Functions may fail for a number of reasons. The caller may have been passed or something may fail within the. For example, a function that opens a file for reading may fail because the file cannot be found. This happens when you have few options. When this happens, you have few options. There is no best way to handle the error. It really depends on the nature of your program. But there are four general strategies to be used that can be used. Handle the error within the function, pass the error back to the caller to deal with it, halt the program, or throw an exception. And remember, we covered halts in the last stream. So handling error within the function. If possible, the best strategy is to recover from the error in the same function the error occurred, so that the error can be contained and corrected without impacting any of the code outside. There are two options: retry until successful or cancel the entire operation. If the error has occurred due to something outside the programmer's control, the program can retry until success is achieved. For example, if the program requires internet connection and the user loses it, the program may be able to display a warning and then loop to periodically recheck for internet. Alternatively, if the user has entered invalid input, the programmer can ask the user to try again. Yeah, that makes sense. An alternative strategy is to just ignore the error and or cancel the operation. So silent failure if y equals 0. So void print int division. We got an integer of x, integer of y, and if y doesn't equal 0, we'll output that. I'd rather do that because it looks better, I think. Okay. In the above example, if the user passes an invalid, i.e. 0, we'll just ignore the print. The primary challenge of with doing this is that the caller or the user will have no way to identify if something went wrong. True. In such case, printing an error message can be helpful. Yeah, that makes sense. However, if the calling function is expected to be called to produce and just okay. Passing errors back to the caller. So, option 2. In many cases, the error cannot reasonably be handled in the function that detects the error. For example, consider the following: int division return x divided by y. If y is 0, what should we do? We can't just skip program log because the function needs to return some value. In the best case option can be to pass the error back to the caller in the hopes that the caller will be able to deal with it. How might we do this? If the function has a void function type, it can be changed to return a boolean. If the function has a void return type, it can be changed to return a boolean. to indicate success or failure. So you got, but we're changing it to Boolean. And if y is equal to 0, it will be false. That way the caller can check the return value to see if the function has failed for some reason. If the function returns a normal value, things are a little more complicated. In some cases, the full range of return values isn't used. In such cases, we can return a value that wouldn't otherwise be possible to occur normally to indicate an error. For example, we got a double of reciprocal, and we got a double and x, return 1 double divided by x. The reciprocal of some x is defined as 1 divided by x. A number multiplied by its reciprocal equals 1. So 0 divided by 0 will return 0, i.e. false. So I think I'm going to need to think about this a bit more. So you got int, do int division, and then int x, int y, and then we're going to be returning x divisible by y. In the above example, if y is equal to 0, we cannot just skip the program logic because the function has a return type of int and therefore needs to return a value. If the function is a void or has a it can be changed to a Boolean to indicate success, true, or failure, false. For example, so we've got a void function of print int division with an integer of x coming in and an integer of y. So if y doesn't equal 0, you can say standard character output x divided by y. Else standard character output error error could not divide by 0. And then that can then become Boolean print int division with my integers coming in as parameters. And then if y is equal to equality, not assignment, is equal to 0, then we will do standard character output, and then we'll print this again. And then we will return false. And I just realized I need a block for this. Yes. And then if it's not equal to 0, we simply just print x divided by y. And then, as always, we return true for Boolean, because we return false here and we want to return true there. Cool. I think the fact that I'm typing it out makes it a lot more easier to understand. Rather than just copying it. Okay, so up next. So that way the caller can, so by changing the return type from void to Boolean, the caller can check the return type to see if the function fails. So wherever we call the function, we can then go back to this to see if it's true or not. If the function returns in a normal value, things get a little more complicated. If the function returns so we're on to something else now. If the function returns a normal value, this is a bit more tricky. In some cases, the full range of return values isn't used. In such cases, we use a return value that wouldn't otherwise be possible to occur normally to indicate an error. So in such cases, we use a return value that wouldn't otherwise be okay. such as the following return type. So we got a double, reciprocal, and then we got a parameter of double x, and then we are returning 1 divided by x. However, what happens however, what if the user calls the function with we will be dividing 1 by 0.0. But we know that the function must return a double value. Well, the function will never return 0.0 as a legit result, so we can return 0.0 to indicate an error, such as the following. So we got constant expression, a global constant expression of double, error, no reciprocal, and we're initializing it because it's a constant expression. We must initialize it. Then in our double reciprocal double x, if x is exactly equal to 0.0, then we return error, no reciprocal. And then outside of the if statement, we'll return true, basically. A sentinel value. So a sentinel value. So the above is referred to as a sentinel value. A sentinel sentinel value is a value that has some special meaning in the context of a function or algorithm. In the reciprocal function, 0.0 is the sentinel value, which indicates that the function has failed. The caller can test the value to see if it matches a sentinel value. So then the caller of the function can test the return value to see if it matches the sentinel value. If it does match, then the caller of the function knows that the function has failed. Okay. However, if the full range of return values can be produced, okay, fatal errors. Okay, fatal errors, which is the third one. Where were we? Fatal errors. No. Oh yeah, fatal errors. Yeah, so holding the program, because we saw last time we can do standard exit or standard at exit. Okay. If the error is so bad that the program cannot continue to operate, this is called a non-recoverable error, or a fatal error. In such cases, the best thing to do is to terminate your program. If your code is in the main function or a function called a, yeah. So, for example, got a double do int division with our integer of x coming in and an integer of y coming in. And then if y is exactly equal to 0, we will do a standard character output. And then we'll print this. And then we will do a standard exit of 1. And then outside of the if statement, we'll return 0 for success. Sorry, return x divided by y. That's what we want. We want to return the double. Okay. And then the final one of the 4 is throwing an exception. And that's one of the 4 strategies to handle errors. The 4th. Because returning a function is a bit more complicated, to pass errors back to the caller. The basic idea is that when an error occurs, an exception is thrown. If the current function does not catch the error, then the caller of said function has a chance to catch the error. If the caller doesn't catch the error, the caller has a chance. If the caller does not catch the error, the caller's caller has a chance. Then if the caller does not catch the, that makes sense. Like you create a function here, then you call it in the main, and if the function here doesn't catch it and the caller doesn't catch it, then the main has a chance to catch it, I assume. Then if the caller's caller does not catch, sorry, if the caller does not catch the error, and if the caller doesn't catch the error, the caller's caller has a chance to catch the error. Yes. So until the main. And then if the main doesn't handle it, then your program will terminate. Okay, cool. So so that was that. So when to use standard character output versus standard character error versus logging. So I'll do that. So modern. So the rule of thumb. And interactive is interactive is status and So basically for the programmers basically, and to help you understand the error of where you've gone wrong. Then for non-interactive so basically if you are user interface and requiring user input, basically use standard character output. Whereas if you're using, you want errors to print if there's a diagnostic or debugging problem, then use standard character error. And then finally, for any application that is transactional in nature, use a log file to produce a transactional log of events to be viewed later. This can include outputting to a log file which is being processed. Okay. Okay, so how are we looking on errors then? So next we're going to do that. I don't think we'll finish today, to be honest. Maybe we'll see how long standard capture input error is. Okay, so it's quite long. Yeah, we're not finishing it today. We'll see where we are in a few minutes. But at the moment, I'm going to take a quick break and I will be right back. Okay, right. Let's pick up where we left off then. All right. All right. Turn that down. Okay. Right. Using standard character output and handling invalid input. We'll see how far we get along with this. Probably won't finish it the whole thing today, but that's okay. Just after error, what are we actually doing after errors? Type conversions, implicit. So, for example, if you divide a integer by a float, the changing there, and you can also do it explicit. Then we're doing functions. Then we're doing pointers, which would be interesting. Then we're doing structs and classes. Classes, vectors. Okay, so we really get into some interesting stuff. And then it's just basically more and more classes. Okay, so we've made a decent progress. So standard character input and handling invalid input. Most programmers have the use. You've been using standard character output, yes. User can enter anything. Yeah, that's true. Because you want to practice defensive programming. Yeah. In this lesson, we'll look at different ways the user can enter invalid text. In standard character input. Before we do, so the insertion operator. First, leaving white spaces. Yeah, I remember that. Which is why when we have a standard character output of enter an integer or whatever, we don't need to have we don't necessarily need to have a line break, because the standard character input will create the line break for us. So validating input. The process. So inline, remember we used inline for our namespaces and global and other functions. So the process of checking whether the user input conforms to what the program is expecting. is expecting is called input input validation. There are three basic ways to do input validation. The first is to first inline as the user types. Oh no. First is as the user types. As the inline user types. Prevent the user from typing invalid input in the first place. The second, post entry after the user types. Let the user enter whatever value they want. Then we validate if correct. Then the third one, again, is post entry. After the user types. Let the user enter what they want. Then let syn character in and the extraction operator of try to extract it and handle error cases. Okay, let me just get rid of that. Some geographical spaces, I'll let you validate them. So what's that? What's that basically saying is the programmer provides. So if the user's input is valid, it returns true, else false. And that's called every time a key is pressed. If it's true, the key pressed and accepted. And if false, it's just discarded. Using this method, you can ensure. Okay, but it doesn't accept it. But surely there must be a way to do it, no? Because I've done it in other languages, so there must be something available in C++. Since strings do not have restrictions, okay. So a sample program. So we've done this one before, so I think I'll just do it again. So include input output stream. We want to double get double. Then within the body of that, we will say standard character output, enter a decimal number. Then we will create a double of x uninitialized. Then we will allow the user to enter x with the exertion operator. Then we will return x. So then we want to ask for an operator, char get operator, and then here we'll do basically the same thing. We'll do standard character output, enter one of the following, and then I'll just copy and paste that. Then we'll do a char operator, uninitialized. We'll allow the user to enter a character input of operator, and we will simply return our operator, making use of the character return type. Then we want to print result, and because we're printing, we want to use a void function. And then we'll want int x. We'll want a char of operator, and then sorry, we won't want an int, we'll want a double, and then operator, and then we'll want a double of y. So then we'll do a standard character output of x, and then operator, and then we'll do another space, and then we'll do y, and then we'll do is, and then we'll do we want to switch our operator, so that in the case of, I'm trying not to look as much at the his solution, just so it gets in my head. So if our case is plus, we want to return? No, we'll just do a standard character output of x plus y, and then a line break, and then we will return. So we don't have fall through, and plus we can only enter one operator. Case, and then minus, and we'll do a standard character output of x minus y with a line break, and then we return there. Why am I getting, I'm getting an error there because my switch, I need a body for my switch. Then we do case times, and then we do a standard character output of x times y, again with a line break. And then we're again returning, and then we do case divide with a standard character output of x divided by y, and then we're going to be doing return again. And then finally, for our modulus remainder, we'll do that. We'll do and then okay, no modulus. Okay, and then in our main function, we will want to create our doubles, double x, and that will be get double, char operator, just so it's clearer. So then we'll get operator. Actually, because that goes out of scope, I'm just going to do opper again. And then we'll do a double of y, and we'll do get double again. And then what we'll do is we will need to print the result, and then we'll simply do x opper, and then y, and then return 0. So that should print all fine, right? So if we do that, enter a number, enter a decimal number, 2.2, enter, so plus 1.1, and we should get 3.3. It's 3.3. Nice. So that allows you to do that, but it also allows you to do whole numbers as well. Now consider the user where the user might be. What if the user enters Q? So let me just do this. Do that. Yeah, so basically now we're dealing with how the user might break it. I don't feel I need to copy that because you can imagine it yourself. Types of invalid input. Actually, do we create a new? No, I think we'll just leave it in here, to be honest. So types of invalid input. We can generally separate input text errors into 4 types. So are we going through all of them? We are. Okay, so what I think we'll do is I think we'll end it here for today. and we will just leave off. So, because that's quite a lot, and I'd rather do it all in one, so I actually know and can memorize it and can take it all in. So, left off at lesson 9.5, standard character input and handling invalid input, subsection types of invalid text input. Okay, yeah, I'll leave it there. So when I open it, it should come back to it. Okay, so day 19. Is the stream actually called day 19? Let me just double check. Day 19, yeah. Okay, at least I know the stream's the correct date, or the correct title. So we'll leave it there for now. So day 19, what did we do today? Error handling, testing the code. We did informal testing, preserving your tests, preserving your tests, automating test functions, unit test frameworks, i.e. third libraries, code coverage, so integration testing, code coverage, i.e. I don't know them off by heart, statement coverage. I know we have branch coverage, and then we have one other coverage, loop coverage. Loop coverage. Okay. Loop coverage, yeah. Loop coverage. Then we did testing different categories of input. And then we did the quiz. Then we did conditional logic errors. We did again infinite loops. We did off by one errors. We did incorrect operator usage. we did precision and how calculating can be can produce errors, and it's usually better to make your floating points literals. Yeah. Okay. Make your floating points literals. Then we did integer division. We did accidental null statements. We did incorrect calling of functions, i.e. not using or not passing in the needed arguments. Then we did using assignment operator, aka rather than an equality operator, which is this one. Then we did quite a lot today. Detecting and handling errors. And the 4 strategies to use. 1, handle the error within the function. 2, pass the error back to the caller to deal with. 3, halt the program. 4, throw an exception. And that's all those. Then we looked at when to use different applications. When to use that in different applications. And then finally, we just finished off with standard character input and handling invalid input, and that's where we left off here. Yeah, cool. And the date is the 17th of August. Cool, so we'll print that, or commit that, sorry. Do that, hide that. Cool, so that's it for today. We're getting into the nitty-gritty things, and then we'll eventually be getting on to things like structs, functions, and creating new things and classes. So if you've been enjoying it like I have, let me know. If you again saw something that I did that I shouldn't have maybe done, let me know. And always feel free to leave a comment, like, subscribe, and all that good stuff. I'll see you in the next one.